Hello everyone and welcome to my living room. I wanted to try something different tonight, and instead of doing the lecture in front of class, I just figured I would record the lecture, and then that would make it possible for you to watch the lecture sort of at your leisure during class. You can pause it when you need to, you can rewind it when you need to, and it will free me up to be able to answer questions as they pop up while you work on your work during this class period. My hope is to kind of make things a little bit more individualized than I've been making them, and also to make it possible for you guys to get more feedback, both from me and in the form of doing things like online quizzes. So, in this video, we're going to talk about the fourth item on our agenda, which is how to use the unit circle in order to find exact values of trig functions of angles. So you guys have already looked at the unit circle this evening, and you've already figured out how to use right triangle trig in order to find the x-coordinate and the y-coordinate of the points that are on the circle. We call those points terminal points, and that's just the word that we use to refer to where the terminal side of an angle intersects with the unit circle. And you guys have already discovered that the coordinates of the terminal points are identified by the cosine and the sine functions. But those are just two of the trig functions. We've also got tangent, secant, cosecant, and cotangent. And so just knowing the sine and the cosine, so both the x and y value of the terminal point, will allow us to find all 6 of those values for all angles that we look at on the unit circle. And so that's what this slide summarizes here. You can see sine is the y-coordinate, cosine is the x-coordinate, and then the other 4 trig functions are combinations or inverses of those coordinates. So what we're going to do right now is just take a look at a couple examples of how to use this information to find exact values of trig ratios for angles. And then if you feel the need for some extra practice afterwards, then find me. I may end up putting some extra practice problems on the board or something. And then once you feel like you're ready, go to Moodle, and then you'll be able to take the quiz that I have set up. Okay, so let's look at some specific examples. Make sure to have your unit circle handy, because that's what I'm going to be using in order to help me figure out what the answer to all these questions are going to be. And you're going to see me looking down a lot. It's because I have my iPad in front of me, and that's where I'm doing all the examples. Okay, so let me get my pointer up here. There's my pen. So our first example, let's say that we wanted to figure out what the secant of pi over 6 was. And you'll have to forgive my sketchy handwriting. I'll get better at this, but it does sort of take my handwriting and make me look like I'm back in kindergarten or something. Anyways, so I'm going to look at pi over 6 on my unit circle. Let me just draw a quick sketch. There's my unit circle. Pi over 6 is right about here. And the coordinates at that point are root 3 over 2 and 1/2. Now I can use that information in order to figure out what the secant of pi over 6 is. The secant is the same thing as 1 over the cosine. So if we look at our ordered pair from our unit circle, cosine is the x-coordinate of the ordered pair. So that's root 3 over 2. That means that the secant of pi over 6 is going to be equal to 1 over root 3 over 2. Now we don't want to leave that as a complex fraction like that, so I'm going to go ahead and rewrite that as 2 over root 3. It basically flips the fraction around. Now my final step, generally mathematicians don't like to leave radicals in the denominator, so what we're going to do is called rationalizing the denominator. It might be something that you remember doing from high school, but it just means that I'm going to get rid of the radical that's in the denominator, and I'm going to do that by multiplying the top and bottom by root 3. So that gives me a final result of 2 root 3 on the top and 3 on the bottom. Square root of 3 times the square root of 3 is just 3 itself. And that would be your final answer. You don't want to take it any further than that, because anything that you do beyond those steps would mean that you would have to do some rounding. And our goal is to get the exact ratios of these trig functions. So let's try another one. Let me clear my work. And we'll look at a new example. Let's see, how about we look at one in the fourth quadrant, 7 pi over 4. Let's say that we wanted to find the cosecant of 7 pi over 4. I've really got to get better at writing this stuff. Let me try that again. Okay, one more time. Cosecant of 7 pi over 4. Where is my 7? There we go, 3 times the charm. Okay, cosecant is the inverse of sine. It's the same thing as 1 over sine. So on my unit circle, I'm going to look at the angle 7 pi over 4. And sine goes along with the y-coordinate of the terminal point. So if I look at my unit circle and look at 7 pi over 4, it looks like the y-coordinate of that is negative root 2 over 2. So that's just the sine. Now if I'm going to get the cosecant, then I want the inverse of that fraction. So I'm going to go ahead and flip that around, and it would be negative 2 over root 2. So just like I did in the previous example, I want to go ahead and multiply the top and bottom by the square root of 2 to rationalize the denominator. I apologize if you can hear my baby screaming in the background with the babysitter. So that would give me a final answer of negative 2 root 2 over 2. And I'm actually not finished quite yet because that answer can still be simplified. The 2 in the numerator and the 2 in the denominator can cancel out. And so that leaves me with a final answer of negative root 2. Okay. So if you need further examples, raise your hand, ask me questions. We can do some more together before you have to take the quiz. But once you get to that point, you get 3 tries on your quiz, and I want you to have the goal of earning a 90% or better. Okay? I might try doing this again sometime in the near future. Hopefully I will get a little bit better with my penmanship with this. Alright? So have fun finding these exact values.